There are some people who say that there's not going to be much impact of climate change. They're often referred to as climate skeptics or sometimes deniers. On the other side, the media kind of reports in a box between that view and the opposing view, which is seen as people who are saying climate change will cause some or a substantial cost. But the rest of the informed opinion is considered unreasonable and therefore not reported because it doesn't fit within the frame that they use to discuss this, even though that's where I would say the majority of climate scientists sit. So, this is the same video that I just showed you, but plotted as a graph. So we've got temperature anomaly, so that's the change in temperature that we've seen against time. And this is going up to the year 2016, and 2016 was the hottest year on record. That was surpassing 2015, which was previously the hottest year on record, which surpassed 2014, which was previously the hottest year on record. If we carry on warming the planet as we are doing, then this is what we're going to see. So again, this is temperature anomaly, so temperature change relative to this baseline. And we can see the black line here represents the same temperature time series as I just showed you on the previous slide. And if we carry on burning fossil fuels, we'll go along the red pathway, which is the fossil fuel intensive pathway. And you can see that there is uncertainty around that. And that's because there is uncertainty in the science. We're not entirely sure what the outcome is going to be of doing that. But the uncertainty in that, there's much bigger uncertainty between choosing to do that or choosing to switch to the blue pathway, which would take us to 2 degrees. Putting that red curve in context of the last 10,000 years, this is what it looks like. Now remember, all of civilization has evolved to cope with the stability that this last 10,000 years has provided us. Indeed, some people would say that's the reason that civilization happened when it did. Because you could start predicting when the rains were going to fall. You could predict how much rain you were going to get. You could predict where the sea levels were going to be. You could predict how high the floods would rise. But we're going to go out of that. We're leaving that behind. And it's the extremes that matter. So that was just the average temperature. But what we need to understand is that's the climate. But what happens on a daily basis is weather. And so this plot here shows you how the distribution of extreme temperatures will change as a result of our warming planet. So actually, this shows you the changes that have already taken place. So the way to understand this is that this is the temperature of extremes that you'd expect in a summer in the northern hemisphere in the base period, which is 1950 to 1980. And basically, a third of the time, you'd expect temperatures to be about average. That's the white area. A third of the time, you'd expect the temperatures to be below average, so that's the blue. And a third of the time, you'd expect them to be above average, and that's the red. So I'm going to play this, and you can see how this distribution has shifted over time. So this is what it looked like in the 1950s and 60s. This is what it's 70s through 80s, 80s through 90s, and this is going into the 2000s. Okay? So what that means is that these really hot extreme temperatures that we never used to see happen are now happening. And the analysis concluded that this hot extreme, which covered much less than 1% of the Earth's surface, now typically covers 10% of Earth's land area. And this is only with 1 degree of warming, okay? The Met Office and the Hadley Centre, which do a lot of climate change modelling in the UK, carried out an analysis and they said, well, what would these extremes look like if we warmed the planet by 4 degrees? Their conclusion was that for a 4-degree mean surface temperature increase, then on the hottest days of the year, the temperature in China would be 6 to 8 degrees hotter than it currently is on the hottest days. In Central Europe, the temperatures would be 8 to 10 degrees hotter than the hottest days that they've currently experienced. And likewise in New York, it would be 10 to 12 degrees hotter. You can just imagine the kind of impact that that has on the infrastructure of a city, on growing crops. So here's what that looks like as a map. Okay, so this is looking for Europe. This is the number of extremely high temperatures. So days where you have nighttime temperatures over 20 or daytime temperatures over 35. So these are temperatures that put lots of stress on a human's body, right? Especially if it goes on for a few days. And what you see is that this is the number of days a year that you'd expect to see that kind of level of temperatures. This is the world as it was from 1960 to 1990. Then it's 2020 to 2050 and 2070 to 2100. And you can see that you start seeing more than 50 days a year in much of southern Europe, such as Spain, Italy, Greece. I mean, these are temperatures reaching these really extreme temperatures more frequently than they currently do in many parts of North Africa. I was in France on holiday in 2003 when one of these extreme heat waves struck. And it was unbearable. I was camping at the time, and you literally could not stay in your tent after the sun rose. We used to spend our days kind of running around between supermarkets to use their air conditioning. I can remember that. But about 15,000 people estimated extra died in France as a result of that. In fact, across the whole of Europe that summer, it's estimated that the number is closer to 70,000 people, excess deaths that summer. This is what that spike looked like. So 2003 was really extreme, nothing like it had been seen before. But by 2040, that's going to be an average summer. And by 2060, most summers will be warmer than that. All right, so that's in our lifetime, that's in our kids' lifetime. You can extend that kind of analysis and do it for the whole world. So this takes the last 150 years. So we can look at that, and when we then say, over that last 150 years, which year was the hottest year on record at that location? And then we can ask the question, at what point in the future will every year be hotter than the hottest it's ever been at that location? So every subsequent year is hotter than the hottest it's ever been. And we can get a date. And this graph then plots that date. So you can see here that in the tropics, we reach that date much sooner. We reach that date in the 2020s to 2030s. So in those areas, every single year is going to be hotter than the hottest year that's ever been experienced at that location. By the 2040s, that's most of the subtropics, and by 2050s, that's kind of the higher latitudes. So that's London, for example, is 2056. And that's because normally we see larger changes in our interannual variability. So some years are very hot, some of them are much cooler. Whereas the tropics, they're much more steady. They have a constant temperature year-round and from year to year. What does that mean in terms of drought, for example? So this graph here shows you how dry the soils are in different parts of the world. It's known as the Palmer Drought Severity Index. The top graph shows you what it's thought to be for the last first decade of the 21st century, sorry. And then what it's predicted to be in 2030 to 39, 2060 to 69, and 2090 to 99. The key thing to understand here is that the color scale, right? So pinks and purples are very, very dry, and blues are wetter. So for reference, this kind of magenta purple was pretty much as bad as it got in the Dust Bowl in the United States. And we can see by about 2060, much of the breadbasket of the United States is experiencing those kind of dry temperatures. Likewise, much of the Mediterranean and the area around Turkey and Ukraine, and also northern Brazil by the later century. All of these areas are becoming very, very, very arid at that point. We know that drought can have a huge impact on crops. So this is a picture from 2012 when a drought struck the United States and wiped out about 30% of their corn harvest across many of their major grain states. This picture here is of California, and it shows you the drought that they've just had over the last 5 years and how it built up from 2011 through to 2015. It just broke this last winter. But this is the worst drought that has ever been recorded in California, and we can use tree ring data to say it's the worst drought that's happened in a much longer period of time than that. There are some people who say that there's not going to be much impact of climate change. They're often referred to as climate skeptics or sometimes deniers. On the other side, the media kind of reports in a box between that view and the opposing view, which is, and this is going up to the year 2016, and 2016 was the hottest year on record. That was surpassing 2015, which was previously the hottest year on record, which surpassed 2014, which was previously the climate scientists sit. So, this is the same video that I just showed you, but plotted as a graph. So we've got temperature anomaly, so that's the change in temperature that we've seen against time, seen as people who are saying climate change will cause some or a substantial cost. But the rest of the informed opinion is considered unreasonable and therefore not reported because it doesn't fit within the frame that they use to discuss this, even though that's where I would say the majority of